Okay, so I just did one of the most bullcrap problems ever. It's so stupid. Okay, so I'll just share the problem right now. I got my thing on the computer so we could write it. So it is the integral. Oh, we're in eraser mode. Whoopsies. We're in the integral of. That's terrible. The integral of. The pen thing's on an uneven surface. That's why. The square root of u squared minus a squared du equals 1/2 u square root of u squared minus a squared minus a squared ln. What is this? I don't even know. Okay, I'll get confused later. Ln absolute value of u plus square root of u squared minus a squared. And absolute value, parentheses, and then the plus c. Of course, you can't forget the plus c. So we have to solve this thing using trigonometric substitution. Now, I'm not sure I did it right, but I said u equals using the trig identities. Okay, where's the eraser? There it is. Using trig identities, I used u equals secant theta, a secant theta, because the a is in there, and it is the constant. The constant is a, and this is u. So u equals this. So then du equals a secant theta tangent theta. I said that, and so we're just solving for this one right here. We're making sure this is equal to that, proving it through trigonometric substitution. So the integral of the square root of secant squared theta minus a squared. No, it's a, because there's the a in the front. A squared secant squared theta minus a. And then du is equal to a secant theta tan theta. So then this is, I was just like freaking so confused. You just split it up. So this is a trigonometric identity. You could take out the a in the front, take out the a in the front, right? Yeah, you take out the a squared in the front, and then you have a to the fourth. Wait, what? That doesn't make sense. I'm not sure I did this right. I think I didn't do it with that. I think I just had secant there. No. I did do it right. I'm just being stupid right now. So you have the square root of a squared times secant squared theta minus 1. Secant squared minus theta. Secant squared theta minus 1 is a trig identity, and that's equal to tangent squared. So you have the square root of tangent squared, the tangent square root of a squared. And then we have this, just bring that down. So you have this, and then you have, it's just, you could take the a's out front actually. I did that in my problem at this step. So then you have a squared because this is an a, and then this is an a, so it's a times a squared, square integral of tangent times secant times tangent. I'll have thetas. But this is not, I'm not a serious like tutor. I'm just some guy on the internet. I don't know why it's like going all the way over here. That's just, okay. So from that step, you have to do some trigonometric manipulation. which, you know, I'm good at manipulation. Just kidding, that's a joke, that's a joke, that's a joke. So then you have secant, tangent times secant is equal to secant squared theta minus 1 times just secant theta. So then you multiply that out, and that equals a squared integral secant to the third theta minus secant theta. And then you recognize that this is equal to, oops, do that, secant third theta minus the integral of just secant theta. Move it down. Okay, and then we have brought this down. So this is another trigonometric identity thingy. This is solved by integration by parts. You have, you know, there's d theta here over here. Let me get the exact way how to do it so I don't confuse people. You have dv equal secant squared x dx, and then it means du. So I'm not going to go through it. If you want to know, look up integration by parts secant thing. If I could go through it for extra practice, but I just simply don't want to. It's long integration by parts. So then the answer to that is answer to that is wait, did I just do this all wrong? I'm not. Let me check something. I have algebra calculator. Hey, look, it's me. So I did this on this calculator to check my work. I plugged in the whole integral of just secant tan squared x, which is what it was up there. And then it solved for this, which just said it was this, which is weird because mine's saying it's 1/2. It's not the first part, but it's weird. Okay. I'm believing what this says. Frick the book. You know. So then we just have 1/2 tan secant. They both have thetas. Those are interchangeable, you know. Minus. We did this. That's that integral. Now it's this term's integral. So this one's 1/2 times ln, the absolute value of secant theta plus tan theta. That's one of your just rules. So then we have this. So up here I have, so u is equal to a secant whatever, and then you plug tangent is equal to, tan is equal to square root of u squared minus a squared, because you do the triangle over here. This is the part of I put this as 1 because I'm just like, no, u, and then, but it would have to be a u or a, yeah, that makes sense. This is why I'm unsure of how I did it. Oh, I have 1 there. I meant to put a. Shoot. Is it too late to unsubmit? Shoot. Okay, well, I think it's too late. It doesn't matter really. It's just a mistake. And then this equals u squared minus a squared. So tangent equals that. Tangent is that over a tangent, which we have the a squared over here, so then so a tangent different if it's a squared. Ah, shoot, I'm so unsure. No. Okay. So then you have 1/2 squared. This is the part that's confusing me. I'm not sure I did this right. I just have 1/2 because it's tangent, and then it's u squared minus a squared times u, because secant is just u minus 1/2 a squared ln absolute value of u plus square root of u squared minus a squared. And that's my answer. They both match up, but it's like I'm really unsure about what, like, how it works in the general, like, ideas. But yeah, that's it. To